Hi, my name is Matt Davis, and I am a faculty at the University of New Hampshire. And we're going to talk about how to measure the slope of the land using a level and a stadia rod. And what we're going to do is we're going to look at how we measure the slope of the land using a level and this stadia rod. And the measurements that we're going to make are the height of the instrument above the ground, the eye height that we see on the stadia rod, and the distance from the instrument to the stadia rod. And with those three measurements, the height of the instrument, the rod height that we see through the level, and the distance between the instrument and the rod, we can then compute the slope of the land, which is shown here as theta. So we'll begin by taking the measurements. So now we're going to use the level to measure the rod height on the stadia rod, and we'll also use the stadia increments to determine how far the rod is from the instrument. The rod height is 3.56. And the increments on the stadia is 0.2 feet, which means that the stadia rod is 20 feet away from the instrument. So we know then that our rod height is 3.56 feet. The distance is 20 feet. We still need to measure the height of the instrument. So when we measure the height of the instrument, we see that it's 4.65 feet. So now these are all of the measurements, and using these we can compute the slope distance. So because we know that our datum is horizontal, and because we know that our eyesight is horizontal through the level, we know that the height of the instrument, HI, is equal to the rod height plus the change in the elevation, Y. So Y is equal to the height of the instrument minus the rod height, and that is equal to 4.65 minus 3.56 feet. So that difference is 1.09 feet. We know that the tangent of theta is equal to that change in distance y divided by the horizontal distance that we measure. So the tangent of theta is equal to 1.09 feet divided by the horizontal distance of 20 feet. 1.09 over 20 is equal to 0.054, and the inverse tangent of 0.054 is 3.1 degrees. So we looked at how to use this basic surveying equipment to measure the slope of the land. We're also interested in knowing where things are positioned on a map. So if we look at a map with a north arrow, and we know that our instrument is positioned at a certain point on that map, we might be interested in knowing the location of another point. And what we need to do to determine that is to determine a bearing to that location relative to north. So we're going to use the instrument to measure this horizontal angle we're going to measure the distance using the stadia as we did previously. And then by knowing this horizontal angle, we can compute this angle, which will be the complement. And then we can determine the easting and the northing coordinates of this location. We can align the instrument with north using a compass to determine the north direction. And then we can set the instrument so that it has a bearing of 0. And once we have the instrument set so that the angle is aligned with north, then we can rotate the instrument to the new position and then measure the angle relative to north. So when we rotate the instrument to view the location, this now reads 310, so we know that we've rotated it 50 degrees west of north. So north is our reference angle of 0, and we measured a bearing that was 50 degrees west of north. And we're interested in measuring the coordinates of this location. We measured a distance of 40 feet. So we know the distance from our reference, which we'll call the origin of 0, 0, is a distance of 40 feet in a bearing that's 50 degrees west of north. So now we wanted to determine its location with easting coordinates and northing coordinates. Because we know the location is west of our current origin, the easting is going to have a negative value because it is to the left of the origin. And the northing will have a positive value. Because our bearing is 50 degrees west of north, we know that this angle relative to east is going to be 40 degrees. So we know that we have a 40-degree angle from west to our point, and we know that it's 40 feet distance. So we now want to compute the coordinates of that point. We have the opposite. We're interested in knowing the opposite, and we have the hypotenuse, and we have this angle. So we know that the sine of the angle 40 degrees is going to be equal to the northing bearing divided by the distance along the hypotenuse, which is 40 feet. So we can solve for the northing is then equal to 40 feet times the sine of 40 degrees. The cosine of 40 degrees is going to be equal to our easting over the hypotenuse, which is 40 feet. So we can solve that to say that the easting is then equal to 40 feet times the cosine of 40 degrees. And the easting will be negative because it is to the west of our origin. So we can cheat and put a negative sign. Okay, so now we can use a calculator to compute the sine of 40 multiplied by 40. And the northing coordinate is 25.7 feet north of the origin. The easting is going to be the cosine of 40 times 40-foot distance. We know that it is west of the origin, so it's minus 30.6 feet. So the coordinates are 25.7 minus 30.6.